Welcome everybody to 15-minute science lessons, the free online learning videos to help support you with your science GCSE qualifications. Today's 15-minute lesson is all about revision, and in particular we're going to look at the AQA trilogy specification, and we're going to have a look at some paper 1 chemistry exam questions today. So what I'm going to do in this 15-minute video is I'm going to pick a series of exam questions. We are going to explode them together. I'm going to share with you the knowledge that you need to access the questions, so we'll write some information around them, and then we'll have a look at actually answering the questions themselves. So let's get started. First question. So first of all, always really good exam practice to highlight that information in the question that's really going to help you answer it. Pick out the bits that you need from the bits that you don't need. So copper chloride used in this investigation contained 300 grams per decimetre of copper chloride. The student used 50 centimetres cubed. Calculate the mass. Now, the first piece of information, quite obviously, that you would need to access this question, well, what is the formula to calculate mass? So to calculate mass, it's the concentration times the volume. Sounds pretty straightforward. This is my concentration. Concentration is obviously the amount of substance, whether it's the mass or the number of moles per unit of volume. So I know that that must be the concentration, and this is the volume. But it's not just as straightforward as that. We're not timesing those two straight away, because that would be a far too easy 3 marks. The first thing we need to remember in order to use this equation, the volume has to be in a unit called decimeters cubed. We can see from the question it's not in decimeters cubed, it's actually in centimeters cubed. So how do we convert that? There is 1,000 centimeters cubed in 1 decimeter cubed. So if we are wanting to convert from centimeters to decimeters, we need to divide that number by 1,000. So the volume is 50. 50 divided by 1,000 gives me 0.05 decimeters cubed. And you do get a calculator in your exam, so please, you might be feeling a little bit panicked, you might just make the odd mistake, get the decimal place in the wrong space, so use your calculator just to double check you've got that number right. So I'm then going to substitute the numbers into the question now that I've got them both. So mass is concentration, which is 300, which I've got from this number here, times the volume. Remember, I'm not going to use 50 because that's in centimetres cubed. I'm going to put 0.05 in because it's in decimeters cubed. Times in those numbers together will give me an answer of 15 grams. Now, in addition to this, you would be expected, or you could be expected, to rearrange that equation. So again, if you're asked for concentration, concentration is mass divided by volume. Again, that volume has to be in decimeters cubed. 9 times out of 10 you're given the volume in centimeters, so making sure that you do that conversion into decimeters cubed. Again, you could be asked to calculate volume, so volume would be mass divided by concentration. Okay, so again, looking at those two, an easy 3 marks. The main thing you need to access this question is that equation there. And if you didn't convert the volume into decimeters cubed, there are still 2 marks up for grabs there. Okay, so definitely marks that we can be picking up. Next question, so we're going on to the group 7, known as the halogens. So this question is about the wonderful group that is the halogens. When chlorine reacts with potassium bromide, chlorine displaces bromine. So we can see that here. The chlorine is now in the compound, bromine is now out of it. So chlorine has displaced bromine in that compound. And we've got to explain why chlorine is more reactive than bromine. Now, when we're talking about reactivity, the information that we need to access this question is the electronic structure. those electrons are responsible for the reactivity of the element. So chlorine is actually above bromine in the periodic table, fluorine, chlorine, bromine, iodine, and then astatine at the bottom. Now in terms of, so we all know that they're in group 7, so this is just additional information at the minute. Group 7 all form -1 ions. That means they need to gain electrons to get that full outer shell. And as you go down the group, the number of shells increases by 1 each time. So fluorine has got 2 shells, chlorine has got 3 shells, bromine has got 4 shells. So it must be something. So the only difference between chlorine and bromine with the electronic structure is the number of shells. They both need to gain 1 more electron to get that full outer shell. So what must be causing the difference in the reactivity is the fact that bromine has 1 extra shell. So let's have a look then. If we look at chlorine, the reason that chlorine is more reactive is because its outer shell is closer to the nucleus. Why is that important? We're going to have a look next. Chlorine is more reactive as the outer shell is closer to the nucleus. And it's closer to the nucleus, so nucleus is the centre of the atom. Chlorine's only got 3 shells, so that outer shell is 3 shells away from the nucleus, whereas in bromine, the outer shell is 4 shells away from the nucleus. Now, the fact that chlorine's outer shell is closer to the nucleus means that there is less shielding, or if you're not familiar with that term shielding, so shielding means that there are less shells in between the nucleus and the outer shell. Or you could also phrase it as there is a greater electrostatic attraction between the nucleus and the outer shell. We should remember from atomic structure that the nucleus is positive because of the protons, and it's the attraction to the positive protons in the nucleus that holds the electrons in place. So because the outer shell in chlorine is closer to the nucleus, then that outer shell is going to experience a stronger electrostatic attraction. It's got less shielding, it's going to have a greater electrostatic attraction. And because it's got a greater electrostatic attraction, that leads us to our final mark. That means it is easier for chlorine to gain an electron. Okay. So if we were comparing it to the full group and not just chlorine and bromine, the trend, and this is sort of additional information that we put round the side, so the trend in group 7 is as you go down, they get less reactive. The reason they get less reactive is the outer shell becomes further and further away from the nucleus. You've got more shielding, you've got a weaker electrostatic attraction between the nucleus and the outer shell, and therefore it becomes much harder to gain that electron as you go down the group to get your full outer shell. Now, group 7, remember, are in contrast with group 1. Group 1, it's as you go down, they get more reactive because they don't want to gain an electron, they want to lose an electron this time. Okay, next question. This one, diamond. Why does diamond have a high melting point? You wouldn't believe in how many times I have seen this question come up on an exam paper. Why does diamond have a high melting point? Now, this question is about the structure and bonding in diamond. So again, before you are answering a question like this, you need to think, right, diamond. Diamond is made of carbon. Carbon is a non-metal. The bonding in non-metals is covalent. Now, with covalent bonding, you should have learnt about two different types of structures, simple structures or giant structures. Simple only contains small number of atoms, giant contains lots of atoms. Diamond is a giant covalent structure. Now, actually, if you'd have remembered that, that is your first 2 marks. Diamond is a giant covalent structure. That just means it's held together by covalent bonds, by shared pairs of electrons, and it is a giant structure, so it involves lots and lots of atoms. Now, sometimes this question can be worth 4 marks. And the next bit would be, it contains lots of covalent bonds which require a large amount of energy to break. But because it's only 3 marks, this one just wants you to write down that lots of energy is needed to break these bonds. So lots of energy is needed to break these bonds. Now, this is the same, so if you are asked about any other giant covalent structure, why that has a high melting point, the answer would be exactly the same. Well, what are the other giant covalent structures? Graphite, you should be familiar with. So again, graphite has a high melting point because it is a giant covalent structure which contains lots of strong covalent bonds that require a lot of energy to break. And then the other one, silicon dioxide. So this bit is interchangeable for any 2 of those. So the question is really asking you, it's not really specific to diamond, it's actually asking you, why do giant covalent structures have a high melting point? Because it doesn't tell you it's a giant covalent structure, you get 2 marks just for actually identifying that bit. Brilliant. Next question, so again, we're sticking with that theme of structure and bonding. Explain the conditions needed for sodium chloride to conduct electricity. Now, the conditions needed for substances to conduct electricity vary depending upon the type of structure and bonding in that substance. So, sodium chloride, again, let's have a look. What do we need to access this question? So this time, sodium is a metal. Chlorine is a non-metal, so we will not have covalent bonding anymore. What we actually will have is ionic bonding. Now, ionic bonding is the transfer of electrons. Electrons move from the metal to the non-metal, and they form a structure called a giant ionic lattice. This is what a giant ionic lattice looks like. Now, all of these chloride ions are negative. All of these sodium ions are positive. Whenever you have pluses and minuses next to each other, you have something called electrostatic attraction. That's very, very strong. Now, in order for this substance to conduct electricity, ionic substances only conduct electricity when the ions can move. So what conditions can these ions move in? Well, in this picture here, it would not be able to conduct electricity because those ions are held really strongly in place because of that strong electrostatic attraction. So in a solid, they would absolutely not conduct electricity. Well, what state would this substance conduct electricity? Well, it would conduct as a liquid. So remember, you turn something into a liquid by melting it, or as a solution. You turn it into a solution by dissolving it in water. And the reason it would conduct electricity in those 2 conditions rather than as a solid is due to the ions being able to move and carry the charge. Okay, so ionic, again, the sodium chloride bit, that bit is interchangeable for any ionic compound. Ionic compounds only conduct when liquid or solution because the ions can move. So that's why I'm linking it to another topic that's also on paper 1, electrolysis. Electrolysis only works in liquids or solutions because the ions have to move to the opposite charged electrodes. Right guys, thank you so much. I hope you found that really, really useful. Again, watch out, and I will be putting up some more videos. Again, 15-minute videos, 15-minute free science lessons to help support you with your science GCSEs.